Factor in the complex number system simply means to put this equation in the form of x times x plus one root plus another root, or you could say minus. So in order to do that, I'm going to set this equal to 0, and I'm going to use completing the square to find the solutions, and then I'm just going to plug them in right there. It's similar to if you had x squared plus 3x plus 2. What you're doing is you're finding the zeros, and you want to be able to put those zeros. Whoops, I wrote that wrong. This should be, no, that's right. Plus 2 and plus 1. So your zeros were -2 and -1, and those zeros are now seen right here as factors. So if you have a 0, if you know that -2 is a 0, then you know that x minus -2 is a factor. So when you write it this way, that's usually the way you see it in the book. I want my zeros right here, and that's how I factor in the complex number system. Alright, let's do this. So if I set that equal to 0 and I complete the square, really the best thing to do on this problem is to add 4, which is half of 4 squared, and also subtract 4. So I've introduced those. So I get x plus 2 squared equals 5, which means x equals -2 plus or minus the square root of 5. So my factors would be x minus -2 plus the square root of 5, clear some space here, and x minus -2 minus the square root of 5. And you can clean those up a little bit if you want, or if it's a multiple choice exam and you see it written a little bit differently, maybe they would have written it as x plus 2 minus root 5 and x plus 2 plus root 5. If you distribute that negative in, that's the way it would be written, most likely. Alright, so that's how you do it for that one. Factor in the complex number system again. Well, here it would be easier if I set that equal to 0, if I just solved it by taking the square, first dividing both sides, and now taking the square root. Now you look at that and you say, well, you can't take the square root, but you can in the complex number system, because it's just going to be I. So x equals 9 halves I, plus or minus 9 halves I. So my factor would be x minus 9 halves I times x plus 9 halves I. This one asks what is the sum of the roots of this. That's actually, there's a little formula for it. It's the opposite of b all over a is the sum of the roots. So the opposite of b is 30 over a, which is 15, so the sum of the roots is just 2. And then this one says find the zeros and graph. So for this particular problem, to find the zeros of this, you would try to factor it if you could. And I don't have the time or the space to do this problem for you, but just to give you an overview, what you would do is you would try to find, it doesn't factor, so what you would try to, well, at least it doesn't factor in an easy way, is you would try to find P are all the factors of -24, the constant term, and Q is the leading coefficient. And there's a property that says if there's a rational root, then it is in the form of P over Q, where P is a factor of -24 and Q is a factor of 1, the leading coefficient over here. So check, just start plugging in numbers and see if 1 works, or 2 or 4 or 6 or 8 or 12 or 24, or negative of any of those. And if you find a 0, then you can use long division to break this down into a cubic, and then you can keep going from there. The easiest way to do it is, of course, to use a graphing calculator and just find a couple of your zeros so that you can at least break it down a little bit. And when you do long division, you can then continue to break this down from a quadratic to a cubic, from a cubic to a, from a quartic to a cubic, from a cubic to a quadratic, and then you can solve a quadratic by completing the square or quadratic formula if it doesn't factor. I've got some examples for you of this one on my website, but I won't do that one for you here. Good luck.